Hello and welcome to Maths with El Profelo. Going to be solving this particular problem. Find x such that x is equivalent to 3 mod 5 and x is equivalent to 7 mod 11. When we actually go through to solve this problem, we're going to solve it first using what you might know from divisibility and playing around with things, and then we'll come back and also solve this using the Chinese remainder theorem. Right? So once again, x equivalent to 3 mod 5 really means that x is equal to 5n plus 3, and x equivalent to 7 mod 11 really means x is equal to 11m plus 7, or n and m are integers. Okay, so if I take this equation, multiply this by 11, we can say that 11x is going to be equal to 55n plus 33. Okay, and similarly, if I take this equation here and multiply this equation by 10, I would be able to say that 10x is equal to 110m plus 70. All right, and if I were to subtract, I would be able to say that x is equal to 55n minus 110m minus, let's see here, 33 minus 70. That would be, if I'm not mistaken, 37. Well, we can just double check here. 33 minus 70. It is 37. So then minus 37. So we have a way of thinking about our particular piece here, right? But notice that this x equaling here, I have a common factor of 55, so I could say x is equal to 55 times n minus 2m minus 37. Okay, well, what does that mean for us? That means that x is equal to, or rather equivalent to, negative 37 mod 55. And if that's the case, if x is equal to negative 37 mod 55, right, if I take negative 37 and I add 55 to it, that's 18. And so I know x is going to be equal to 18t plus 55, where t will be some integer. Okay, and we would be able to say, actually, this is incorrect. It's not 18t, it's 18 plus 55t, right? But if t is 0, then we have 18. So our solution, or at least positive solution, would be x equals 18. All right, and now if I want the general solution, it's going to be 18 plus 55t, where t is an integer. Now, this involves some manipulation that you may think about, you may not think about. The Chinese remainder theorem is another way that we could approach this. Okay, so if we approach this using the Chinese remainder theorem, what we have there is, we'll just rewrite our equivalence. X is equivalent to 3 mod 5, and x is equivalent to 7 mod 11. We want to make sure that 5 and 11 are relatively prime, and they are relatively prime. Okay, so then we need to find our product, which big M is going to be equal to 55. We need to find our minor products, right, which would be 55 divided by 5, so that would be 11, and 55 divided by 11, so that would be 5. So now we have a new system that we're going to solve, and we're going to need to solve this new system, which will be 11x1 needing to be equivalent to 1 mod 5, and as well 5x2 needing to be equivalent to 1 mod 11. All right. By inspection, x1 has to equal 1, right, because 11 times 1 will be 1 more than 10, which is divisible by 5. And by inspection here, x2 can equal 9 because 5 times 9 is 45, and that's 1 more than 44, which is divisible by 11. So we have our solutions, right? And then our form of the solution is x is going to be equal to 3 times 11 times 1 plus 7 times 5 times 9. Mod, and then that's going to give us, let's see here, put this into our calculator, 3 times 11 times 1 plus 7 times 5 times 9. So that's going to give us 348, which is going to be equivalent to, well, now let's start subtracting 55 because that's my big M. So minus 55, minus 55, minus 55, minus 55, right? Do it a few times until I get to a number less than 55, and so I see that that's going to be equivalent to 18 mod 55, which once again gets us to that same solution of 18 as the least positive solution. And of course, adding 55 or subtracting some multiple of 55 will keep us with other solutions. We can check this one obviously by inspection and say 18, is it 3 more than a multiple of 5? Yes. 18 is 3 more than 15. Right, 18, is it 7 more than a multiple of 11? Yes, 18 is 7 more than 11. So clearly 18 works, and we would have other solutions that work, right? So this has been Maths with El Profe Lo. As always, if you have questions, please do reach out.